Okay. Actually, so in the previous lecture already we discussed so number of problems for discrete random variable. So now we move on to the continuous random variable, problems for continuous random variable. Okay. So discrete random variable means your probability function called as probability mass function. Okay, shortly denoted as PMF. Okay, so your probability distribution function should be denoted PMF. Okay, that means probability mass
Sir,
function.
switch off the light now.
Lighter. Now okay. So now visible board
Yes,
clearly.
sir.
So this is okay, wa? Board visible?
Yes, sir.
Some
Yes,
okay.
sir. Yes, sir.
Okay. So your probability function distribution is named as probability mass function. Okay. So what are the conditions for discrete random variable? One by one you can tell. So what are the conditions going to be satisfied for discrete random variable? So anyone tell?
Night number.
Sum of all the event equal, sum of probability
Yeah.
equal to 1.
Sum of all probability values should be equal to 1, and your all probability value should be greater than or equal to.
Greater than equal to.
Okay. So similarly here the probability distribution function of continuous random variable is denoted as f of x. Okay. So here p of x, now here f of x. So f of x, it is called as probability density function. Okay. Here the probability distribution function called as probability mass function. Here the probability distribution function of a continuous random variable is probability density function. Okay. So here these are the conditions for discrete random variable. Similarly here we have, okay, so the first condition should be your probability distribution function should be
Sir, not visible, sir.
not visible.
Yes.
That means you have some
That area is particularly not visible. It's shining on the
This
board.
light
That's
is
why.
falling on that
Yeah.
side.
okay, just we'll adjust that one. So again some shining is there, no? So which is not the light. So now okay, Rama.
Yes, sir.
Yes, sir.
Okay. So here your probability distribution function should be greater than or equal to 0. Already you know that here the values of the random variable here finite and countable. Okay. But here the values of the random variable infinite and also uncountable. Okay. So infinite number of values you having, also uncountable. So therefore always your probability density function defined in some interval. Okay. So here you are writing for all x belongs to minus infinity to infinity. So in that interval, do you have infinite number of uncountable numbers? Okay. So therefore here finite number of countable numbers, here infinite number of uncountable numbers. That's why we are defined. So therefore your probability distribution function should be greater than or equal to 0 for all x belongs to in this interval, minus infinity to infinity. Okay. So this is the one of the conditions. Here also p of x greater than or equal to 0 for all your x values. Okay, here you can write here sum of all probability values becomes, you should denote it by summation of the probability distribution function should be equal to 1. How to define here? Here you have the interval minus infinity to infinity. Then how to sum? So you can find out sum of all values. Here also you have to sum of all values in that interval minus infinity to infinity. So here we notated the symbol summation. What you have to define here? How to sum? You can take the integral minus infinity to infinity f of x dx equal to 1. Then only you are getting the sum of all your probability in that interval. Okay. So
Voice is not clear.
So here your sum of 1 minute. Again you are getting. Okay. So your probability function should be greater than or equal to 0 for all the interval x belongs to minus infinity infinity, and sum of all probability values becomes 1. So here the values of the random variable defined in some interval. So that's why I'm writing integral over minus infinity to infinity f of x dx equal to 1. Okay. So these two are conditions for discrete. Here, this is the condition for continuous random variable. Okay. So keep this in your mind, then only we can solve the problem. Okay. So one more thing for both of the cases, already we know that formula CDF. Okay. CDF means cumulative distribution function. So what is the cumulative distribution function formula? F of x equal to probability of x less than or equal to x. Okay. Here, CDF, cumulative distribution function, is defined as f of x equal to, so probability of x less than or equal to x, which means that, how to write that one? Less than or equal to x means you have to write minus infinity to x f of x dx equal to 1. Okay. So this is the CDF formula for discrete random variable. Here this is the CDF formula for the continuous random variable. Okay. So here P of x less than or equal to x means you can substitute your x values here. Then you have to take some discrete values. Here this is defined in the interval. That's why you are writing minus infinity to x f of x. P of x less than or equal to x means, which means that minus infinity to up to x. Okay. F of x dx equal to 1. Okay. So both of the cases. So now this is the conditions for discrete and continuous. So we have any doubt for this?
No, sir.
No, sir.
Okay. So you just note down the points. Okay. So then only we can solve the problem. Okay. So CDF formula. This is the CDF formula for the continuous. Okay. So now we move on to the problems. So write the first problem. The probability density function of a continuous random variable x is f of x equal to c into e power minus modulus x minus infinity less than x less than infinity. Okay. So here the question asking, find the value of C, and second one, cumulative distribution function of the random variable x. Okay, so here the probability density function, that means probability distribution function for a continuous random variable defined here. That function is C into e power minus modulus x minus, so this function valid for this interval minus infinity to infinity. Okay, so here the question asking find the value of C as well as cumulative distribution function of the random variable. Okay, so how to find out that one? So first we have to discuss the first case. So what is the first condition? So what is the condition for continuous random variable?
A probability distribution should be greater or equal to 0, and minus infinity to infinity fx df equals to 1.
Dx equal to 1. Okay, so this is the condition for a continuous random variable. So using that condition, we have to find out the value for C. Okay, so now we have to substituting the minus infinity to infinity. So what is your function? Nothing but C into e power minus modulus x. So dx equal to 1. Okay, so here C is a constant. So I'm taking outside from the integration. So 1 minute, this connection is poor network connection. So I will rectify this. Wait. So here we have some poor network connections. Now it's okay. So now okay, wa?
No, sir, we can't.
No, sir.
No, wait. So
No, sir.
here we have some poor network connection. That's why for the interruption. Wait. I will.
So now it's okay, sir.
Now okay, wa? Okay. So now it is okay.
No, sir.
Students, anyone tell? Now it is okay, wa? No, wa?
No, sir.
No, sir.
No, sir. No, sir.
It is
No,
too
sir.
much light
I will
reflecting
check the
off.
network connection.
अभी कुछ नहीं दिख रहा सर, nothing is-
सर मीटिंग छोड़ के गए हैं।
पांडे
कैसे हो ना?
Sir, you're in mute.
क्या करा? ठीक।
Okay, so now okay.
Yes
Now
sir.
visible. Okay. So okay. Now continue that one. Okay. So here, so our aim is we have to find out the value for C. So this is a condition for a continuous random variable. So using that condition, we have to find out the value for C. Okay. So here, now we have to substitute the given function C into e power minus modulus x. That is your f of x. Now we have to substitute here. So here C is a constant. So you are taking outside from the integration. So C into integral over minus infinity to infinity e power minus modulus x. So dx equal to 1. So how to integrate this one? Now it is possible for integrating this function. So anyone tell? How can you integrating this function? So anyone tell?
E to the power minus e to the power minus mod x upon minus 1.
How to differentiate? How to integrate mod x? First of all,
First we will break mod x.
that is not possible. E power minus modulus x. Modulus x means you having both plus x as well as minus x. Okay. So both.
First we will define sir.
sir we have to take
So,
two limits,
yeah. So first we have
minus
to define
infinity
what.
to 0 or 0 to infinity.
Yeah. Actually, we have to define modulus x. So therefore, here when you get minus x means when x less than 0. Okay. So when you get plus x means when x greater than 0. Okay. So mod x means, so you having both minus x and plus x. So when you say minus x, modulus x becomes minus x means your x should be less than 0. So when you say modulus x plus x, when x greater than 0 means modulus x becomes plus x. Okay. So therefore, here we have the interval minus infinity to infinity. Okay. So we can't integrating directly here. That's why you just break the intervals, that become 0. Okay. So therefore, here this becomes, these are your x values. Okay. So in this interval represented as x less than 0, here in this interval represents x greater than 0. Okay. So minus infinity to 0 means your x value should be less than 0. Okay. Less than 0. Therefore 0, minus 1, minus 2, minus 3, minus 4 up to infinity. Minus infinity. Greater than 0 means 1, 2, 3. Plus 1, plus 2, plus 3 up to infinity. So therefore, so here modulus x becomes, in this interval, modulus x becomes minus x. Here in that interval, modulus x becomes plus x. Okay, there you are getting, that is a negative one. So this is a positive one. So now here we can't integrate directly here. So minus infinity to infinity e power minus modulus x dx equal to 1. So therefore, this interval should be divided into two equal parts. One is minus infinity to 0. Another part is 0 to infinity. Okay, so clear? So how to breaking that interval? Students, mute yourself. Subayan Chaudhary, mute yourself here. Okay. So now this interval you are writing you can split it into two parts. One is minus infinity 2 into 0 e power here minus modulus x. Okay, minus modulus x. Another one is 0 to infinity. So 0 to infinity e power minus modulus x. So dx plus here dx is equal to 1. Okay. So now this interval broken into two intervals, minus infinity to 0 and 0 to infinity. So now c into minus infinity to 0 e power minus. So in that interval, what is your modulus x value? That becomes minus x. Okay. So someone disturbing, so mute yourself. Someone disturbing, mute yourself. Okay. So here in that interval, what is your modulus x value? Minus infinity to 0. Minus infinity to 0, your modulus x value becomes minus x. Therefore, e power minus of minus x into dx. Here 0 to infinity e power minus modulus x becomes, here you are getting plus x. Okay. So dx equal to 1. So now you have to integrating that function. Okay. So how to integrate? So here c into, this is e power x. So what is the integration of e power x? What is the integration of e power plus x? E power x integration is e power x. So limit from minus infinity to 0. Okay. So here e power minus x. So what is the integration of e power minus x? E power minus x by minus 1. Okay. So limit from 0 to infinity, that should be equal to 1. Okay. So now you have to substitute your upper and lower limit. This is becomes e power 0. Now substituting your lower limit, therefore one minus sign exists, e power minus infinity. Okay. This is your upper and lower limit. Here plus into minus, that becomes minus. Okay. So here substituting your upper limit minus infinity, your lower limit becomes e power 0. Okay. Instead of x equal to 0 means you are getting e power 0. That is equal to 1. Okay. So now what is the value for e power minus infinity for? What is the value for e power minus infinity?
0.
0. That becomes 0. So therefore you can substitute here e power 0 value is 1. This is 0. 1 minus 0 here. So this is 0. E power 0 value is 1. We are getting 1. Okay. So now we can simplify that one. So here 1 plus here 1. So 2 into c. So 2c equal to 1, which implies c equal to 1 by 2. So this is your values. Okay. So the first case over. Okay. So using the condition for the continuous random variable, you are getting the value for c equal to 1 by 2. Okay. It's clear? Do you have any doubt for this one? For finding the value for c.
No, sir.
It is okay, va? Okay. So now we move on to the second case. Okay. So now we move on to the second case to find CDF of the random variable x. Okay. So CDF of the random variable means this is the formula f of x equal to integral over minus infinity to x f of x dx. Okay. So this is your CDF function formula. So here x is defined in the interval minus infinity to infinity, but your function is having modulus x. So function you having modulus x means, so the interval broken into minus infinity to 0. Another one is 0 to infinity. That's why you having cumulative function for, you should find out for two cases. So what is here? When x less than 0 means what is your cumulative value, cumulative function? When x greater than 0. Okay. So what is your f of x? These two cases you have to find out. Okay. So here the interval f of x defined in the interval minus infinity to infinity. Since your function having modulus x, so modulus x means we need to broken into two intervals. One is less than 0, another one is greater than 0. So when x less than 0 means what is your function? When x greater than 0 means what is your function? Okay. Now look at your upper limit. So your upper limit should be x. Therefore, your function you are getting in terms of the variable x. Okay. Previously, probability discrete random variables, you are getting some discrete values. Okay. 1 by 2, 1 by 3, 1 by 4 likewise. Okay. So here the function defined in some intervals. That's why you are getting your probability. That means your cumulative distribution function of the random variable. You are getting in terms of the variable x, because your upper limit should be here x. Okay. So therefore you are getting the function in terms of the variable x. So how to get that one? So these two cases you have to find. So find the cumulative distribution function. First I am taking when x less than 0. Okay. So when x less than 0 means your function f of x becomes integral over minus infinity to x. Okay. So what is your function? C into e power minus modulus x. So dx. Okay. So here already you got the value for c. What is that value? Minus infinity to x. That becomes 1 by 2. Okay. So 1 by 2 into e power minus modulus x dx. Okay. So here your x value should be less than 0. Okay. So here your x, in that case you are getting x less than 0. Okay. So x less than 0 means minus infinity. Don't change the limit x. Okay. So minus infinity to x. 1 by 2 is constant, taking outside from the integration. So here in this interval means here you are considering x less than 0. Okay. So here minus infinity to x is nothing but x less than 0. So x less than 0 means what is here? E power minus your modulus x becomes minus x. Okay. So dx, since here x should be less than 0. Okay. So x less than 0 means this one. So therefore here 1 by 2. Now e power x. So e power integration is e power x. So e power x limit from minus infinity to x. Okay. That is your integration. So now you have to substituting the limits. So 1 by 2, you can replace x by x again. So that's what.
Sir,
What's your doubt? What's your
sir,
doubt?
can you explain the previous? Can you explain the previous step?
Previous means previous step.
Yes,
this step.
sir. How?
Ah.
Yes, sir. How minus of
Ah.
minus x came? That is one. That one.
Okay. Minus infinity to x. Okay. So minus infinity to x. So here, whether it is x less than 0, whether it is x greater than 0. So minus infinity to x means if you have to substitute x equal to 0. So minus infinity to 0. So minus infinity to 0, what is that? Already I told that. So this is your interval minus infinity to infinity. So this is 0. Okay. In that interval is nothing but x less than 0. In this interval becomes x greater than 0. Okay. Here you have the case, don't substitute x value here, x equal to 0, because we need to find the function in terms of the variable x. So here you can assume that this x value becomes 0. Okay. So minus infinity to 0 means your x should be greater than 0. So x greater than 0 means your modulus x becomes minus x. Your x greater than 0 means what you have to get? Modulus x becomes x. So that's why I'm substituting here. 1 by 2 is constant outside from the integration. So e power minus infinity to. Here, don't substitute your x value. This is the minus infinity to 0. So minus infinity to 0 means this is x less than 0. Okay. Minus 1, minus 2, minus 3. That's why modulus x becomes minus x. I have written modulus x becomes minus x. Now, minus into minus plus x, e to the power x. So e power x integration is e power x only. So minus infinity to from limit from minus. It's clear? Now it is okay?
Yes,
Okay. Now integrate that one. So now replacing your upper limit x again by x. Okay. So e power x, your lower limit becomes instead of x, you can substitute your lower limit becomes minus infinity. So your e power minus infinity is 0. Therefore, you are getting e power x by 2. So therefore, here your cumulative function is e power x by 2. Okay. Similarly, we have to find out the another case when x greater than 0. What you have to get? So x greater than 0 means okay. X greater than 0 means how to write? You are writing x to infinity. Clear? X greater than 0. So what is your x value? So 0 to infinity. X greater than 0 means how can you write it in the integral? So 0 to infinity. So don't substitute your x value. Okay, because we need to get the function in terms of the variable x. So x greater than 0 means your x value becomes 0 here. So 0 to infinity. That is the interval of greater than 0. So remaining you have to do that. Okay. X greater than 0 means x to infinity. C, already you know the value for C. Here e power x greater than 0 means your modulus x. In this interval, x greater than 0. Modulus x becomes plus x. So therefore, e power minus x. So dx. Since your x should be greater than 0. Okay. So here 1 by 2 is constant, taking outside from the integration. So therefore, e power minus x integration is e power minus x by minus 1. Limit from x to infinity. Okay. So now you have to substitute your upper limit and lower limit. So 1 by 2, your upper limit, that means e power x minus means minus.
Sir,
e
your
to the
screen
power
is not visible, sir.
Same setup, sir. Now it is okay, wa?
No, sir, it's
Yes,
still
it's
white.
visible, sir.
Sorry, it is not. Now okay, ma?
No, sir, I think it's the connection problem in my place, sir.
Again connection problem, ma?
I think so, I don't know.
Oh, it's okay, sir.
Connections, there is no problem.
I'll rejoin again.
The board is usual, sir.
Okay. Now, what is the value for this one? So minus e to the power minus s. Now you are substituting the limit minus e power minus infinity. Now substituting your lower limit means one minus n exists. Already you having minus x. That becomes e to the power. Okay, you can replace x by x. So therefore e power minus x. So okay, which means that here you have 1 by 2 e power minus x by minus 1 should be written as minus e to the power minus x. Limit from infinity to, that is x to infinity. So 1 by 2. Okay. Here minus e to the power minus infinity. That is your upper limit. Now substituting your lower limit. So already having minus sign, that becomes plus. So you can replace x by x. Therefore e power minus x. Okay. So e power minus infinity 0. So therefore you are getting e power minus x by 2. So this is your value for cumulative distribution function for x greater than 0.
Sir,
Ah,
sir,
what's your doubt?
but we defined that probability distribution function that minus infinity to x. But when you take x
Minus?
greater than 0,
Ah,
minus infinity to x. But when you take x greater than 0, you have written x to infinity. But so we defined minus infinity to x only. PDF function we
minus,
defined fx equal to
yeah,
probability of x less than
here,
x.
here, minus infinity to 0, then 0 to infinity. Okay, so these two cases are here. Now assuming this is your x value, this is your x value. Okay, so therefore minus infinity to x. So minus infinity to x means this interval becomes x less than 0. Okay, minus infinity to x. That means minus infinity to 0. You can assume that that interval become minus infinity to 0. X less than 0. Here 0 to infinity means this interval becomes x greater than 0. Okay, so that's why I'm writing here
Yeah.
to infinity. Your x value becomes 0. So 0 to infinity. So 0 to
So,
infinity means you.
so
What's your
but
doubt?
when we define cumulative distribution function in discrete random variable, we defined fx equal to p capital X less than x, and in continuous random
Yeah,
variable we define
yeah.
so in
Okay,
continuous
wait.
random variable.
Yeah, x less than or equal to x. Okay,
This is
x
in
less than
so
or
this is
equal to
in yes. So this
x.
one is
Still
fine. But
discrete
in case
random.
of yes, so but in case of continuous random variable, we have written
Continuous
p.
random
So
variable means for continuous random variable, this can be written as minus infinity to x f of x dx. This can be written as in this form minus infinity to x. Actually, for example, 1 minute before that, for example, in for continuous, okay, for continuous random variable means probability of x less than or equal to a. For example, x equal to a. So probability of x less than or equal to a means it should be equal for probability of x less than a. Okay, less than or equal to a is
okay.
probability of x less than a. Your probability of, for example, uh, a less than or equal to x less than or equal to p means it is equal for probability of a less than or equal to x less than p. It is equal to probability of a less than less than x less than or equal to b. Okay. Again, it is equal for probability of a less than x less than. Okay. Here, x less than or equal to a, it is equal to less than a also. Less than or equal to x. There are these three. All the three are here. That is equal. Probability of a less than or equal to x. A less than x or equal to b. A less than x. So all the things are equal. Now clear?
So here x means it take value till infinity.
Yeah, x means don't substitute here. X less than or equal to a means you can that is you are writing here x less than a here x okay x from uh, here x belongs to your range space of the variable. Okay,
Yes.
so therefore
Okay. Okay, sir.
x belongs to
Okay, sir. Okay,
minus
sir.
infinity to infinity. Okay, so now it
Okay,
is good.
sir. Okay.
So therefore, in your first case, x less than 0 means e power x by 2. X greater than 0 means e power minus x by 2. Okay, so clear? Okay. So now, so if you have any doubt in this problem, so students, if you have any doubt, otherwise we move on to the next problem.
Yes, sir.
Okay. So no doubt.
No, sir.
Okay. Shall I move on to the next problem?
Yes, sir.
Okay.
Yes, sir.
Okay. So here, probability density of function of a continuous random variable is defined. Okay.
Sir,
F of
nothing
x
is visible. Sir.
Yeah. What's what?
Is visible.
Not visible.
Nothing is visible, sir.
भाई सब दिख रहा है तेरा नेटवर्क खराब है चेक कर
Network issue, Arpit.
Again it.
भाई कभी ऊपर चलता है
Sites.
ब्राइटनेस आता है.
Sites visual sir
Okay.
he is having network problem
So today we have some network, poor network connection. Yeah.
yes
Sir,
sir.
we have always poor.
So now visible. Yes. Okay.
Yes,
So
sir.
here, okay. So probability density function of a continuous random variables given in the problem f of x equal to f of x in that interval 0 to 1 your function value becomes ax, 1 to 2 means your function value a, 2 to 3 means your function value 3a minus x otherwise. So otherwise means x greater than 3. Okay. So x greater than 3 means your function value becomes 0. Okay. So here the question asking first one as usual, find the value of a. Okay. Second thing, CDF of the random variable x. Okay. So both the things are asking. Okay. So how to get that one? Look at your previous problem. So same thing, same procedure you have to follow. Okay. So here, so we know that the condition is for a continuous random variable is minus infinity to infinity f of x. So dx equal to 1. Okay. So minus infinity to infinity, we can't substitute the function directly here. Okay. Because function defines some intervals. Okay. So 0 to 1 and minus 1 to 2, 2 to 3 and otherwise greater than 3. Okay. So how to split up that interval? Minus infinity to infinity.
Sir, minus infinity to 0, then 0 to 1, 1 to 2, 2 to 3,
Yeah.
and
Okay, very good.
3 to infinity, sir.
Very good. So minus infinity to 0 f of x dx and 0 to 1 f of x dx and 1 to 2 f of x dx and next one is 2 to 3 f of x dx, then 3 to infinity f of x dx equal to 1. It's clear? So minus infinity to infinity according to the given condition. So we have to dividing into some number of intervals, minus infinity to 0, 0 to 1 and 1 to 2, 2 to 3 and 3 to infinity. So now we have to broken into some number of intervals. Okay. So now we have to substitute one by one here. What is your function value for this? Okay. So what is the function value for minus infinity to 0 f of x dx?
0 sir
To define. Remaining other all intervals.
अभिजय माइक बंद कर.
Yeah. Only function value for
Sir, 2.
okay. So mute yourself. Someone disturbing. Yeah. So mute yourself. Okay. So minus infinity to 0, your function value nothing to define here. So only define 0 to 1, 1 to 2, 2 to 3. So these intervals, your function value defined. Other interval should be 0. Okay. So therefore, your first case 0, your second case. So 0 to 1. So 0 to 1, your function value becomes ax, a into x dx. Then 1 to 2. So 1 to 2, your function value becomes a. So a into dx. Next 2 to 3. So 2 to 3, your function value becomes 3a minus ax. So dx. Okay. Now your fourth interval 3 to infinity. So here also up to define 2 to 3. So 3 to infinity, that is other interval, your function taking the value 0. So here also this interval, fourth interval becomes 0. That is 1. Okay. So now we have to integrating the function here. So a is constant. Here integration of x is x squared by 2, limit from 0 to 1. Here a is constant, integration of dx is x, limit from 1 to 2. Here both the term involving the constant a you are taking outside from the integration. Remaining 3 into dx, 3x, minus x into dx, minus x squared by 2. So limit from 2 to 3, that is equal to 1. Okay, so now you are to substituting your upper limit and lower limit. So what is the value for a? You can simplify that. What is the value for a? So anyone tell the answer?
1 by 2, sir.
Sir, 0 to 1 will be 2.
Okay, after simplification, final answer. So I need the final answer. A equal to 1 by 2.
1 by 2,
1 by
sir.
2.
Yeah, 1 by 2 is correct. So a equal to 1 by 2. So after simplification, you are getting a equal to 1 by 2. Okay, so the first thing over. So next you have to find out the second thing. So cumulative distribution function of the random variable. Okay, so it is over. So now we move on to the cumulative distribution function. So CDF of the random variable x. Okay, so we have to find out these intervals. Okay, so first we have to find out 0, 1. So that's why you are consisting when x less than 0. That means first you have to find out x less than 0. Next you are considering 0 less than or equal to x less than or equal to 1. So next you have to considering 1 less than or equal to x less than or equal to 2. Next you have to find out 2 less than or equal to x less than or equal to 3. And fourth case, x greater than 3. Okay, so these things are you have to find out. So 0 to 1 means x less than 0, what your function, 0 to 1 and 1 to 2 and 2 to 3 and x greater than 3. Okay, so these are the things you have to find out one by one. Okay, first we move on to x greater than 0. So x less than 0. So first things, when x less than 0. Okay, so what is your function? F of x equal to probability of x less than or equal to x. So therefore here x taking the value 0. X taking the value 0. So x less than 0 means how to write this one? X less than or equal to 0 means what is your interval?
Infinity to 0, minus infinity to 0.
Minus infinity to x, sir.
To 0, don't substitute your value because since x equal to 0. Okay, so x less than or equal to 0, here x valid from less than 0. So f of x dx. Okay, what is your function? Minus infinity to 0. Here x take, that is x equal to 0 here. Okay, so x equal to 0 means minus infinity to 0, function not defined here. Okay, minus infinity to 0. Less than 0, function all other intervals, your function value becomes 0. So therefore, here the first case, function not defined. That's why 0, you are substituting f of x equal to 0. So therefore, integration of 0 is nothing but 0. Okay, so therefore, your first case becomes 0. Okay, so this is over. Next, we have to find out 0 to 1. When 0 less than or equal to x less than or equal to 1. Okay, so in that interval, you have to find out f of x. Directly, I am substituting here 0 to 1. So, okay, p of x, that means here. So, here directly I am writing 0 to, sorry, your function minus formula becomes minus infinity to x f of x dx. Okay, minus infinity to f of x dx. So here x 0 to 1 only they were function. You can find out in this interval. Okay, so how can you substitute here? Minus infinity to 0 and 0 to 1 and 1 to infinity. Okay, this is the formula for computing CDF. So here function valid from minus infinity to, you can broken into minus infinity to 0 and 0 to 1 and 1 to infinity. Okay, so 1 to infinity, sorry, 1 to x. 1 minute. 0 to 1, how can you split? Minus infinity to 0 into f of x dx and 0 to 1 f of x dx and 1 to x. So that goes here minus infinity to x varies from 0 to 1. Therefore, it is written as minus infinity to 0 and 0 to 1 and 1 to x. Okay, but here function value from 0 to 1, 1. So don't write all the intervals. You are writing only 0 to 1. Okay. So
Sir, your voice is not clear.
so remaining all other cases are that is value from. Okay, so 0 to 1.
So your voice is not clear, sir.
Not clear.
Okay, so 0 to 1. So what is the function value here? The function value becomes a.
Sir, you will not
Sir, we can't hear you.
1. Okay, therefore it can be written as your.
So 0 to 1 is
Sir,
ओए कुछ सुन ले भाई
Sir. Hello, sir.
X is nothing but x. Limit from 0 to. Okay, so now we want
Sir, sir, we can't hear
Sir,
you.
the audio is not clear, sir.
so if you have any doubt,
Sir, it is between
Audio
0
was
to
not
1.
clear.
Sir, we couldn't hear you.
So you are not audible at all.
Sir, in the interval 0 to 1, the function is ax. In the interval 0 to 1, the function is ax.
So you are not audible, sir. So your voice is not clear.
students, anyone?
Sir,
So your voice is not clear, sir. Your
Sir,
voice is not clear, sir.
0 to 1, it's
the
X,
function is
sir, not
ax.
भाई 0 to 1 रुक जाओ यार, आवाज तो आ जाने दो.
0 to 1, 0 to 1. आवाज नहीं आ रहा, 0 to 1.
हाँ भाई.
Sir, voice is not coming, sir.
So
So you are
students,
not audible, sir. So you are not audible, sir.
Only I will continue the class.
So you are not audible, sir. Your voice is not clear.
So students,
Yes, sir, it's fine now.
do you have any doubt? Anyone reply?
So 0 to 1, the function
we
becomes
couldn't,
a.
Do you have any connection problem?
Sir,
we couldn't hear anything while you were explaining, sir.
Just like, can you tell from again? Because nobody was able to hear you.
Yes, sir.
Audible, sir, audible.
Shubhang, right?
Yes, sir.
भाई
Shubhang,
अबे क्या कर रहा है अर्पित?
बेटा Shubhang.
तू ही पढ़ा ले बे आज अर्पित.
अबे आवाज आ नहीं रहा था सर. 0 to 1 पता नहीं क्या लगा रखा है 0 to 1.
अब ये लोग डाउट पूछ रहे हैं भाई, आवाज नहीं आ रही है. चलो ब्रश कर रहा हूँ जस्ट अभी.
म्यूट सर, म्यूट.
Okay, so now it is okay. So today, so many issues here. Okay, so anyone have doubt for this one?
Sir, that is AX,
Sir,
sir,
could
not
you
A.
explain it again? We couldn't hear anything.
Yeah, AX, what is your A value? A value becomes 1 by 2.
Sir, function is AX, sir.
Huh?
Sir,
Sir,
can you
that
tell
X
from
will come
starting?
between 0 and 1, sir. In the interval.
Sir, function is AX.
Sir, could you explain from the starting, please?
Sorry, AX, sorry.
क्या कर रहा है बे?
A into X. So your A value is 1 by 2, therefore X squared by 2. So 0 to X. So you are getting X squared by 4, sorry. X squared by 4. Okay, so minus infinity to X means, so your interval valid for 0, here you can find out the interval 0 to 1. So this can be splitted into minus infinity to 0 and 0 to 1 and 1 to infinity. Okay, so therefore we have to function valid from only 0 to 1. That's why I consider the interval 0 to 1. Okay, similarly we have to do that for second case. So therefore here you are getting X squared by 4. Okay, so next we have to find out the another case when 1 less than or equal to X less than or equal to 2. Okay, so what is your function? So directly you should try. This is 1 to 2 only valid. Okay, so 1 to 2 f of x, sorry, minus infinity to, don't try, minus infinity to into f of x, so dx. Here minus infinity to 0 and 0 to 1, then 1 to 2, and 2 to infinity. You can write the split up, that means x. 1 to 2. Your x values up to from 1 to 2, that is x. Since your value x equal to 2 here. Okay, so 0 to 1, then 1 to 2. Okay, your x value up to 2. So minus infinity to 0, then you have to split up 0 to 1 and 1 to 2. So your upper limit should be here x equal to nothing but 2. So here one by one you have to find out that one.
Sir,
So,
before you said only 1 to 2, no, sir.
Sorry, sir. Actually, 1 to 2 we can't move directly. Okay, because your formula becomes minus infinity to x. Previously, we have when 0 less than or equal to x less than or equal to 1. So your function is f of x equal to minus infinity to x f of x dx. Okay, so here we can't directly, we can go for the interval 0 to 1. So that will pick up the interval minus infinity to 0, then 0 to 1. Okay, so this is your nothing but x. here your x value becomes 1. Okay, minus infinity to 0 and 0 to 1. So minus infinity to 0, function not defined. So 0 to 1 case only we are defining. 0 to x, f of x dx. Your x value becomes 1. Okay, so we have to move. Similarly here, minus infinity to x. So how can you split up here? We need up to 2. So that's why I'm writing minus infinity to 0 and 0 to 1, then 1 to 2. Okay, so that is 2 equal to, that is your upper limit. Okay, so 2 up to, you have to split the interval up to 2. So that is your value here. Okay, so now you can substitute here. So now we have to substituting this. So minus infinity to 0, that is 0, and 0 to 1, your function value, that is ax, ax dx, and 1 to 2 is your x value. Okay, your x taking the value 2, up to 2. So f of x, 1 to 2, what is your value? Function a. So a into d. So here a is a value, you know that 1 by 2. Your x integration is x squared by 2. Limit from 0 to 1. Here a is 1 by 2. Dx integration is x. Limit from 1 to x. Therefore here 1 by 2, that means 1 by 4. 1 by 4. Okay. Here you can replace x by x. Therefore you are getting 1 by 2 into x, your upper limit x, your lower limit becomes 1. Okay. So therefore 1 by 4 plus x minus 1 by 2. Okay. So this is your second. If you are simplifying now, there is no problem. So 4 you are taking common LCM. So 1. So this is 2 into x minus 1. After simplification, you are getting 2x minus 2. So therefore 1 by 4. Therefore, here in this interval is 2x minus 1 by 4. So clear? Anyone have the doubt for the second case?
No, sir.
Minus infinity to x, you can split up in minus infinity to 0, 0 to 1, up to 1 to 2. In that way, you are moving. Okay. So minus infinity. So your x value here, your upper range is 2. So that's why you have to split up the range up to 2. So minus, in that way, you are in the interval. Minus infinity to 0 and 1 to 2. Okay. So clear? Similarly, the next case, when 2 less than or equal to x, less than or equal to 3. Okay. When 2 less than or equal to x, less than or equal to 3. Okay. So therefore, here 2 less than or equal to x, less than or equal to 3 means your formula becomes f of x equal to minus infinity to x, f of dx. We can't move to directly to, okay. We can split up the interval minus infinity to 0 and 0 to 1, then 1 to 2, okay, then 2 to 3, okay. So 3 means your x value. That is your x value. You can move on this way. So 2 to 3, this is your x value becomes 3. Okay, in that case. So therefore, minus infinity to 0, your function becomes 0. So 0 to 1, your function value is ax dx. Okay, and 1 to 2, your function value becomes a dx, and 2 to 3. Okay, 2 to 3 means that is your x value. So 2 to 3, your function value is 3a minus ax into dx. Okay, so 1 by 1 I have to integrate. A 1 by 2, x value becomes x squared by 2. Okay, here a equal to 1 by 2 integration of dx is nothing but x, limit from 1 to 2. Here, both the terms involving a taking outside integration. So therefore 1 by 2. So 3 into dx, 3x minus x squared by 2. So limit from 2 to x is equal to 2x. Now you can simplify that one. Now you have to simplify that one. What you have to get? 1 by 2 here 0 to 1 limit. So therefore in your first case you are getting 1 by 4. Okay, here 2 minus 1, upper limit 2, lower limit 1. 2 minus 1 means 1, that becomes 1 by 2. So here 1 by 2. Okay, so 1 by 2. Now substituting your upper limit is same. You can replace x by x, 3x minus x squared by 2. What is your lower limit? Lower limit becomes, you can replace 2. So 6 minus, okay, 3 into 2, 6. This is x squared up. So therefore 4 by 2, that becomes 2. X minus 2. Now you can simplify that one. So 1 by 4, 1 by 2. You can write. So 1 by 2, 3x minus x squared by 6. 6 minus 2, that becomes minus 4. Now you can simplify that one. What you have to get? So now 1 by 4, 1 by 2. This is 3x by 2. Okay, this is minus x squared by 4. Then minus 4. Okay. Now you can take in common LCM. 4. Now you are taking common LCM 4. You are getting 1. Here you are getting 2. So here 6x. Here minus x square. Here 16. Now you can simplify that one. This is 3 6x minus x square.
Sir, 2.
Ah.
Minus 2, sir, not minus 4.
This one,
No, sir, below.
No.
That.
1 by 2. So minus 4 by 2, that is minus 2. Okay, so therefore 8 minus 8. So 3 minus 8, 6x minus x square. 3 minus 8 means 8. Common taken will say 8. So 3 minus 8 means minus 5. 5 divided by 4. So 6 minus x square plus 6x minus 5 divided by 4. Okay, so this is over. 2 to 3 is over. Next we have to find out greater than 3. When x greater than 3. Okay, so when x greater than 3 means f of x equal to minus infinity to x f of x dx. Okay, your x value should be here, upper range is 3. Therefore you can split out minus infinity to 0 and 0 to 1 and 1 to 2, then 2 to 3. Okay, so greater than 3. Here we need greater than 3. So greater than 3 means that becomes 3 to infinity. Okay, so minus infinity 0, 0 to 1, 1 to 2, and 2 to 3. So your x value becomes here 3 to infinity. No need to find out that one. Okay, because the cumulative of all those things. Okay, surely you are getting this becomes 1. Okay, no need to find out that one. surely you are getting this. When x greater than 3 means your function value becomes 1. Okay. So no need to get 3x greater than 3. So therefore, greater than 3 means you don't know about the x value. So okay, therefore, so all cumulative value, all cumulative distribution of function. So therefore, we know that sum of all your probability values becomes 1. So therefore, you can minus infinity to you are getting plus infinity. That's why your function value, cumulative distribution function value is 1. So no need to find out that case. Okay, when x greater than 3 means directly you are writing that is 1. So it is clear?
Yes, sir.
Yeah. Okay. So x less than 0 means function 0, 0 to 1 means we are already you have to get some value for the value. So 1 to 2, 2, 3, 3, and x greater than 3 means no need to get. So because you can get minus infinity to up to infinity. Therefore, your cumulative distribution function that becomes 1.
Sir, enough, sir.
Yeah, 2 hours, yeah.
Sir, that's for all today, sir. Very tired, sir.
Yes,
Very
sir.
tired.
So tired, sir.
Okay, just one problem. Okay, after that we'll finish it. Okay.
Sir, next
Sir,
sir,
up to 10:40 only we have.
Okay, just
only 10:40, sir. Again class, sir.
okay.
Till 30, 3:30, sir.
Just 5 minutes. Okay, we'll complete that problem. Just 5 minutes. Just only one
So
problem.
give that question, sir. We will complete by ourselves.
Yeah,
Sir,
you can,
homework, sir. Homework, sir.
Homework,
Don't
sir.
do it, sir. Homework, sir. Homework.
homework. I will give some tips for solving this problem. Okay. This is your homework problem. Okay, just I am giving.
Sir, enough for the day, sir.
Okay, yeah. Just one problem. That is your homework problem. I will give some tips.
Yes.
You can solve that problem. Okay.
Sir, but nothing visible, sir.
Yeah, it is visible here.
अबे मत बोलो बे, कुछ मैसेज आने लगता है फिर दिमाग खराब कर रहे सिविल वाले करके.
Mute yourself.
Shubhank, mute yourself.
Okay, ba. So in that problem, nothing to define. This probability distribution function, nothing to define. This is a probability mass function. This is not a, that means this is not a probability density function. Okay. One distribution function is given. Okay. So now here the question asking, so this distribution function, we can show this is a probability density function for a continuous random variable. Okay. So show that this distribution function is a probability density function. Okay, that is the case. Another one, if it is probability density function means we should find out the cumulative distribution function. Find its distribution function. So cumulative distribution function and distribution function both are same. Okay, so therefore this is a probability distribution function. So you must show that This is a probability density function. Okay. The next case, if it is probability density function, means you should find out the corresponding distribution function. So these things are asking in that question. Okay. How can you show this distribution function is probability density function? Anyone tell?
Sir, if we integrated, it will be equal to 1, sir.
Summation equal to 1.
Above first one, sir.
So your
And the sum will also be 1.
okay. So you can show that minus to prove. Okay. So minus infinity to infinity f of x dx equal to 1 to prove this. Okay. So therefore minus infinity to infinity, you can find out only the left hand side. So you should find out left hand side only. So left hand side is minus infinity to infinity f of x. So dx, it should be equal to 1 means, so given distribution function is definitely is a probability density function. Okay. So if it is probability density function means you can find out your distribution function. Okay. So clear? So okay. So minus infinity to infinity, we can't we can't directly substitute in this interval minus infinity to infinity because function value from one case is less than 0, another case is greater than 0. That's why you are splitting minus infinity to 0. Okay, then 0 to infinity. So minus infinity to 0 is less than 0. Your function value becomes 0. Okay, so nothing but this is p of x. Okay, this is your function. Okay, that is p of x. So minus infinity to 0, that becomes here. This is 0. Only function exists 0 to infinity only. So 0 to infinity is your function is x into e power minus x squared by 2 into dx. Okay, so you can integrate that one, you will be getting 1. So how can you integrate? If any idea, if you have any idea?
X equal to x square equal to.
Sir, we'll take x square as t.
You can't integrate directly here.
Sir, we'll use substitution.
Yeah, very good. Substitution method. So you can try for substitution method. You can take t equal to x squared by 2. So surely you are getting this becomes 1. Okay. So because 1 means so the given function distribution function is probability density function. Okay. So using substitution method easily you can get easily you can integrate this one. So suppose substitution method is not working. For example, x into e power minus x is given. Substitution method not working here means then we can go for another method. So what method? So product of two function. One is algebraic, another one is exponential. That case you can go for Eilert procedure. Integration by parts. Okay. Follow the Eilert procedure. So, okay. All the things are you know. Okay. So this is over. So similarly, you can find out CDF of the random variable x. So therefore, you can write there are two cases here existing. One x less than 0. Another one is x greater than 0. Greater than 0 or greater than or equal to 0. There is no problem. Okay. So these two cases you have to find out. Okay. So this is a homework one. You can do in your own way. Okay. Well. So attendance for aerospace students. Roll number 1 is there. Just give your attendance.
Yes, sir. Present, sir. Roll number 1 present.
Number 2.
Present, sir.
3.
Present, sir.
Show your face here. Just at the time of
Present,
attendance
sir.
given, you can show your face. You should just
Present, sir.
3. 4. Okay, super. 4.
Yes, sir.
5.
Present, sir.
6.
Present, sir.
7.
Present, sir.
7. 8.
Present, sir.
9. Okay. 9 absent. Number 9 absent. 10.
Present, sir.
11.
Present, sir.
12. 12 absent. 13.
Yes, sir.
12 present, sir.
12 present.
Yes, sir.
12 present or absent?
Present,
Actually,
sir.
you are coming in the different link. There is no problem for civil. Okay, civil they are using this its own link. So you are entering in the different link. That's why I'm taking the attendance. So number 12 present or absent?
Present, sir.
Okay. 13.
Yes, sir. Yes, sir.
14.
Sir, there's no 14.
Okay. 15.
Present, sir.
16.
Present, sir.
17.
Present, sir.
18.
Present, sir.
19.
Present, sir.
20. 20. 12 present, 20 absent. 21.
Present, sir.
22. 22. 22 absent. 23.
Present, sir.
24.
Present, sir.
25.
Present, sir.
26.
Present, sir.
27. 27. Okay. 27 absent. 28. 28. 29.
Present, sir.
30.
Present, sir.
31.
Present, sir.
32.
Present, sir.
33.
Present, sir.
34.
Present, sir.
35.
Present, sir.
36.
Present, sir.
37.
Sir, there is no 37.
Okay. 38.
Present, sir.
39.
Present, sir.
40.
Present, sir.
41.
Present, sir.
42.
Present, sir.
43. 43. 44.
Present, sir.
45. 45. 46.
Present, sir.
47.
Sir, there is no 47.
Okay. 48.
Present, sir.
Up to 49. Your class.
Sir, 50, sir.
Okay. 49.
Present, sir.
Okay. 50.
Present, sir.
Okay, ma. So these are the absentees, sir. 9, 20, 22, 27, 28, 43, 45. So, okay, correct?
Correct.
So the 2, 4, 6, 7 absentees, sir, today. Aerospace students. So I have written the absentees number in the board.
Give them a
Monday also.
Okay, pa. So civil now there is no problem. Attendance I will take directly from the meet link. Okay. So
Yes, sir.
thank you, students. Thank you.
Thank you,
Thank you,
sir.
sir.
Yes,
You can
sir.
leave.
Thank you,
Okay.
Thank
sir.
you, sir.
Somebody can get some.
Thank you, sir.
अबे ऑनलाइन आओ बे जल्दी लॉबी में बैठा हूँ.
Lipa,
Thank you,
Lipa.
sir.
Thank you, students.
Sir, 45%, sir.
46%.
45, sir.
Your number? 45.
Yes, sir.
Okay. What about 9, 20? 22, 27, 28, 43.
So 43 is also present, sir. So 43 is also present, sir.
You are 43, yeah?
Sir?
You are 43, yeah? Your number is 43,
Yes, sir.
yeah? Okay.
Yes, sir.
Okay.
Yes, I am 43.
Okay. Okay. So remaining 9, 20, 22, 27, 28. These are all absent, huh? So Chirag Pandya, Ankrudi, Sudhir, Soumyajit, Date. You can leave the class one by one.
I guess so, sir.